Hello all, my name is Krishnak and welcome to my YouTube channel. So guys, today in this particular we'll be seeing how we can plot decision trees in random forest. Now many of you know the theoretical explanation of random forest, and you know that random forest is basically a bagging technique. Internally it uses many number of decision trees in order to do the classification or the prediction, right? And it may be with respect to your regression problem statement, and it may be with respect to your classification problem statement. But still, we should try to understand that how this particular decision tree is constructed and how it looks graphically, right? Suppose if I use 20 decision trees inside my random forest, right? But how does it actually look? In yesterday's video, I had already shown you how you can plot decision trees by using a new feature in sklearn in the recent version, which is called as, let me just show you, plot underscore tree. Now, by using this also, we can also apply it to random forest and try to visualize the diagrams. Now, first of all, what I'm going to do is that I'm going to import pandas, matplotlib as usual. And now I have a data set which is called as iris dataset. This iris dataset is actually present inside Seaborn. So if I show you this particular dataset, sorry, it is not in Seaborn, it is basically in sklearn.datasets, import load underscore iris. I'm going to import one more library which is called as from sklearn import tree, and this will actually be used for doing the prediction. Then we'll also be using random forest classifier, okay, in this particular case, because this is a classification problem. So I'm going to use from sklearn.ensemble import random forest classifier. Now, when I want to apply this random forest classifier inside this iris dataset, what I'm going to do is that I'm going to initialize random forest classifier with n underscore estimators is equal to 20. By default, it actually takes 100 decision trees, guys, but now I'm actually taking just 20 to make you understand and show how it looks like. Now, random underscore state is equal to 0. I've actually kept it, and you can keep any value as such. And then I'm loading the iris dataset. Remember, inside my iris dataset, what I can do is that I can create my X, that is my independent features like iris.data, and my dependent feature like Y, which is nothing but iris.target. Right? So this is my data set, and what I can do is that I can completely replace all these things by X, and this I can replace it by Y. So this is my X and Y, that is independent and dependent feature, and this is how my classifier is getting trained. Now, once my classifier gets trained, which is actually a random forest classifier, if I want to see all this particular 20 decision trees, I can actually get all those information from classifier, that is clf.estimators underscore. Okay, when I click this, you will be able to see all the decision trees, all the 20 decision trees that are that have been initialized, and what are the parameters that have got selected. So here you can see all the 20 decision trees. Now, in order to see this particular decision trees, right, all you have to do is that you want to see it visually, right? There are 20 decision trees which you want to see it. Now, suppose for the first decision tree you want to check it out, what you can do is that you will just be writing plot.figure, you give some figure size, okay, and then whatever you have imported from sklearn import tree, what you're going to do is that you're just going to write tree.plot underscore tree clf.estimators, and here, since this is a list, right, this is a list of decision trees, you can just give any index that you want to actually see. Suppose I want to see the first one, I'll just execute, right? So this is my first decision tree that has been initialized in the decision tree classifiers, right? Now, similarly, I want to go and see my second decision tree. Suppose my second decision tree looks something like this, right? So like this, you can actually check out any number of decision trees that are basically used. Suppose there are 20 decision tree. I just want to see the decision tree with index 20. Sorry, it should not be 20. It should be 19, because 0 to 19 is nothing but 20 count. So here you can see that it is basically showing you the 20th decision trees. And again, this is the difference that you can actually find out of some or the other way. And as you know that random forest uses bootstrap aggregation, right? So it may be selecting randomly the features, and it will be splitting based on the purity, right? Based on the purity split, based on the information gain. Now, still, what I did is that I tried to figure out, can I display all these decision trees by using the same function, that is tree.plot underscore tree, right? So for that, what I did is that I did a for loop, okay, for I in range length of clf.estimators underscore, and I started plotting with respect to this clf.estimator underscore I, right? Now, The problem was that when I was printing this, I was printing this particular information. What had happened is that now this plot tree actually uses one canvas, and top of that it will be replacing the images. So because of this, we were not able to see all the images. So it is not possible just by using plot underscore tree to display all the decision trees at one go. Okay, so for that you basically have to use the index. Let me just try with print also if possible. I'm not sure whether with print it will be printing or not. Okay, here with print it prints so many values, but I'm not sure about the decision trees whether it is getting printed or not. Decision tree diagrams, no, it is just getting one is only getting printed, but all the other information that you see over here with respect to all the decision tree is getting displayed over here, right? Now what I can do is that I can still use the same thing. I'll just copy it, and suppose I write this over here, just a second. Okay, and instead of using plot underscore tree, I can also write export underscore text. Now once I do this, okay, and once I execute it, I don't require this. And if I execute it here, you can see all the decision tree, how it is actually getting classified. Yes, diagrammatically we cannot visualize each and everything, but yes, all the other information I can see for all the 20 decision tree, how it is actually classified. But still, if you want to see all the 20 decision trees, how it looks like, I'll give you a suggestion, guys. Download everything, every of this particular diagram as images, and then you open that images and show it in front of your Jupyter notebook. So I would like to give you that as an assignment. Please do let me know if you're not able to do that. In some of the other videos, I'll try to upload that also. So again, just to repeat, guys, what all we did, we imported iris dataset. So we applied random forest classifier. We imported sklearn, from sklearn imported tree, and please note, this is with respect to the recent version of sklearn, that is 0.21, and this is available in Python 3.7. Okay, and if you also want to update in Python 3.6, you just go and try to write pip update sklearn. So that will actually work out. I'll just Google it, how to update the sklearn library itself. So yes, this was all about this particular video. And okay, just let me revise again. After taking this, I did the fit. Then by using dot estimators, I can see all the decision tree classifier. Then what I did is that based considering the index, I can actually plot this decision trees like this, which will be available over here. The code is like this. I want you all to try, guys. What I'll do is that this time I'll not be giving this code in my GitHub. Please do try, learn this thing, and please make sure that whenever you're opening this notebook, you open in Jupyter 3.7. Sorry, not Jupyter, Anaconda 3.7 version, and just try to execute it. So you can also use export underscore text to get the latest version, like how the decision tree was getting classified. Now here you can see all this information is with respect to one decision tree, right? Then this information is with respect to the another decision tree. Like this, all the decision tree information is there. So I hope you like this particular video. Please do subscribe to the channel if you have not already subscribed. I'll see you all in the next video. Have a great day. Thank you one and all. Bye-bye.